For generations, we've had this story, right, about the universe. Big Bang, predictable expansion, galaxies forming slowly, patiently, over billions of years.
Yeah, a solid narrative built on decades of physics, observation.
Exactly.
Yeah.
But now the James Webb Space Telescope, way out there in the cold and quiet, it sent back a message.
A message that's, well, shaking things up.
Shaking things up is putting it mildly. It seems to suggest that whole story might be fundamentally wrong.
It's pretty dramatic stuff.
These discoveries are so profound, so unexpected. They're making top scientists, even Nobel laureates, ask this really unsettling question.
Which is?
What if our basic grasp of the cosmos is just flawed? Webb's seen things that, well, according to our theories, they just shouldn't be there.
Like what specifically?
Ancient galaxies, way too big, too mature for their cosmic age, and a universe expanding faster than our physics can actually explain.
Right, the two big ones.
So what did Webb see that's threatening to, shake the foundations? How do we get here?
It's a huge question.
Stick around. We're going deep into the discoveries that could literally rewrite cosmic history. And hey, if you're ready for this, hit that like button right now. Let us know your biggest question about space down in the comments.
What's so fascinating and honestly a bit unsettling is how this hits right at the heart of the standard model of cosmology. Lambda CDM.
Which isn't just a theory, it's the theory.
Exactly. It's been the grand narrative, the bedrock of astronomy for ages. It explains almost everything we see.
Like the Big Bang's afterglow.
The cosmic microwave background, right. And the huge structure of galaxies, that cosmic web.
So what's in this model? Remind us quickly.
Okay, so basically, Big Bang start, hot, dense. Today, it's about 5% normal stuff, stars, planets, us.
Okay.
Around 25% dark matter, invisible stuff, but its gravity holds galaxies together.
Right.
And then the biggest chunk, 70%, is dark energy, this mysterious force pushing everything apart faster and faster.
And this model worked really well for a long time.
It did. Passed test after test, rock solid, until now.
Until Webb.
Until Webb. Every great story needs a plot twist, I guess. Webb was built to look back, fill in the gaps in that story, see the first light.
But instead,
it started finding these huge, gaping plot holes. People are genuinely calling it a crisis in cosmology.
wow, a crisis.
Yeah. Two massive problems staring us in the face. One, the universe is expanding too fast.
The Hubble tension.
That's the one. And two, Webb keeps finding these, well, frankly, impossible early galaxies. Too big, too old, too soon.
Okay, let's unpack that first one. The runaway universe, the Hubble tension.
Yeah.
How does that work? Can we
Okay.
break that down like the car speed analogy?
Yeah, that's a good way to think about it. Imagine you've got two super precise ways to measure a car's speed.
Okay.
One way is you know exactly where it started, you know all the forces acting on it, so you calculate its current speed.
The theoretical speed.
Exactly. The other way, you just point a radar gun at it and measure its speed directly, right now.
And obviously those numbers should match.
They should match perfectly if you understand everything correctly.
So in cosmology, the starting point calculation comes from the early universe.
Precisely. From that faint heat left over from the Big Bang, the cosmic microwave background, the CMB, physicists use the standard model, lambda CDM, to look at the CMB and predict how fast the universe ought to be expanding today.
And that gives...
That consistently gives a number around 67 kilometers per second per megaparsec.
Just remind us, a megaparsec is huge.
Oh, incredibly huge, about 3.26 million light years. So for every 3.26 million light years further out you look, things are moving away 67 kilometers per second faster. That's the prediction.
Okay, and the radar gun, the direct measurement.
That's done by looking at things in the nearby universe. Astronomers, led by Nobel winner Adam Rees, use specific types of stars, Cepheids, and exploding stars, supernovae, as cosmic distance markers, really precise ones.
And measuring them gives...
A different number, consistently faster, around 73 kilometers per second per megaparsec.
67 versus 73. Doesn't sound like a huge difference, but in cosmic terms.
It's massive. It's a tension, a real discrepancy that shouldn't be there if the standard model is complete. For years, people hoped it was maybe a measurement error, something slightly off.
But then Webb came along.
Exactly. Webb was supposed to settle this. Adam Rees's team used Webb's incredible power to remeasure those Cepheid stars with way more precision than ever before. They were looking for any tiny error in the previous Hubble measurement.
Had it.
And Webb confirmed the Hubble measurements, the faster rate, the 73 number, it's real. The discrepancy isn't going away. It's not an error in the telescopes.
Wow. So ruling out measurement error, that makes it much more serious.
It really does. It deepens the mystery significantly. Like Rees himself said, if Hubble and Webb agree, we have to take this seriously.
Not the tools.
It's not the tools. It might be our fundamental understanding of the cosmos that's, well, incomplete.
That is a truly mind-bending conclusion.
Yeah.
Decades of science questioned.
Right. And if that wasn't enough, then came the galaxies.
The impossible galaxies.
The impossible galaxies. See, the standard model gives us a timeline for the early universe, the first few 100 million years after the Big Bang. It should have been kind of quiet, cosmically speaking. Meaning gravity needs time, a lot of time, to pull together the first wisps of gas, ignite the first stars, and then slowly build up tiny, messy proto-galaxies.
So finding a big, well-formed galaxy back then.
Would be like finding a fully grown oak tree just minutes after you planted the acorn. It just shouldn't happen according to the physics we know.
Yeah.
Defies the whole timeline.
Oh, Webb found them.
Webb found a whole forest of them, seriously. It sent back images of these shockingly massive, well-structured galaxies from way earlier than our theories allow.
Can you give an example?
Sure. Take jwst Z13-0. We're seeing it as it was just 325 million years after the Big Bang.
That's incredibly early.
Incredibly early, and it's already way more complex, way brighter than any tiny infant galaxy has a right to be. It's substantial.
Okay, well, any others?
Oh, yeah.
There's ZF-UDS 7329. This one somehow got bigger than our own Milky Way. Bigger than the Milky Way.
Bigger than the Milky Way, and then it just stopped forming stars, all within the first billion years.
How is that even possible?
Well, that's the problem. Our models say the huge halo of dark matter you'd need to pull together that much stuff that quickly just wouldn't have had time to form yet. It's like it skipped ahead billions of years in its evolution.
So these aren't just weird anomalies. They're fundamental puzzles.
Deep, fundamental puzzles. They suggest one of two things, really. Either star and galaxy formation was ridiculously, unbelievably fast in the early universe.
Faster than physics allows.
Faster than our current physics allows. Or the physics itself, the rules about how structure forms, needs a major rewrite.
Neither sounds like an easy answer.
Not at all. It's a huge challenge for cosmologists.
Okay, we're really living through an incredible moment here.
Yeah.
This is like watching science happen in real time. The James Webb Space Telescope isn't just giving us pretty pictures.
No, it's forcing a genuine rethink.
Rethinking our most basic ideas about everything. If you find this journey, this dive into the unknown, as fascinating as we do, make sure you hit subscribe. And ring that notification bell because you seriously won't want to miss where this goes next.
It's unfolding right now.
Absolutely. And let us know in the comments. What's the most mind-bending space idea you've ever come across? We'd love to hear it.
So you've got your best theory, lambda CDM, crashing head-on with your best observations from Webb. What happens?
You get a crisis.
You get a scientific crisis. It's exactly where we are. These two things, the Hubble tension, those impossible galaxies, they aren't small wrinkles you can just iron out. They are deep cracks forming in the foundations.
So what are scientists exploring now? What can explain this?
Well, they're looking at possibilities that honestly used to be considered pretty fringe or just, theoretical ideas. For the Hubble tension, maybe our whole idea of dark energy is wrong. The standard model assumes dark energy is constant, always the same strength throughout cosmic history. But what if it's not? What if it's dynamic? Changes over time.
Dynamic dark energy.
Yeah. That could potentially explain why the expansion seems faster now than the early universe data predicts. It would mean cosmic forces are way more complex, more fluid than we thought.
That's a huge change. What else?
Or maybe it's gravity itself.
Einstein's theory. General relativity.
The very same. It's been unbeatable for over a century, but maybe it works differently on these enormous cosmic scales. Or maybe it behaved differently right near the Big Bang. Some physicists are seriously looking at alternative theories of gravity now.
That sounds radical. Challenging Einstein.
It is radical, but the data is pushing us there. And the impossible galaxies, they're just as revolutionary.
What could explain them? Superfast formation.
Maybe the very first stars weren't like ours. Maybe they were true monsters. Hundreds, even thousands of times bigger than the sun.
Monster stars.
Yeah, burning incredibly hot, living fast, dying young, and just seeding the universe with heavy elements much, much quicker than our models predict. That could jumpstart galaxy formation.
Okay, that's one idea.
Another idea points towards, exotic physics. Unknown particles, maybe. New forces we don't know about. Something that fundamentally sped up how structure formed right at the beginning, gave these galaxies a massive head start.
This is where it gets really wild, doesn't it? We're standing at this cosmic crossroads,
Looking out at something far stranger than we imagined.
and these anomalies, these problems. Not just problems, they're clues.
Clues that could lead to the next huge leap in understanding, the next scientific revolution.
And it's pushing scientists to think about ideas that were, like, way out there before.
Absolutely. People are revisiting ideas like Roger Penrose's cyclic universe.
A Nobel laureate. What's his idea?
He suggests our Big Bang wasn't the beginning, but maybe a bounce from a previous universe that collapsed.
About.
Yeah. And maybe these huge, old-looking structures Webb is seeing, maybe they're echoes or even leftover bits from that previous cosmic age.
Whoa. Okay, that is mind-bending.
It really is. And other ideas, even more speculative, like our whole universe existing inside a black hole.
Seriously, inside a black hole.
It's a theoretical possibility some are exploring. The bizarre physics inside might, potentially, explain both the weird expansion and the rapid galaxy growth.
These sound like science fiction.
They're highly theoretical, for sure, but the fact that serious scientists are even discussing them shows just how deep this mystery runs. We might be on the verge of finding new dimensions, new forces. Maybe our universe is just one bubble in a multiverse. The possibilities are staggering.
So Webb went looking for answers,
Built to answer our oldest questions about where everything came from.
and instead it gave us deeper mysteries.
Deeper, more fundamental mysteries. The data is solid now, confirmed by Webb. Something truly strange is happening.
Okay, let's summarize. 2 key confirmed anomalies.
1. A universe expanding too fast. Faster than our best model predicts. No wiggle room left on the measurement.
Confirmed by Hubble and Webb.
Confirmed. 2. Ancient galaxies, way too massive, way too mature, existing far too early in cosmic history. They shouldn't be there yet.
And these aren't minor tweaks.
No, these are serious challenges. Direct hits to the standard model of cosmology, the story we've relied on for half a century.
So where do we go from here? Do we have any answers yet?
Honestly, no, we don't have the answers yet. The scientific community is buzzing, exploring everything. Could it be a new type of dark energy? A flaw in Einstein's gravity? Completely new laws of physics we haven't even dreamed of?
It feels like we're on the cusp of something huge.
We absolutely are. We're seeing the first signs of a major shift, and it's important to remember. The universe isn't broken. Our models are broken, or at least incomplete, and as they break, they're actually opening the door.
Opening the door to what?
To a richer, stranger, more complex, more awe-inspiring reality than we ever dared to predict.
The cosmic detective story has definitely just begun. And we're all here, watching the most thrilling chapters unfold right now. What incredible truths do you think are waiting just around the corner?